So what I just talked about in my previous video, where we used two different methods to multiply complex conjugates, we're going to use that down in example number 2. Okay? I think Alex will ask you to do synthetic division with this imaginary zero, but I like to review what we just practiced. So let's take a look. Example 2. Find all other zeros of p of x, which is this thing right here. Okay. Now look at the p of x though. I'm not going to highlight the whole thing. P of x, the degree is 3. So I'll make a note of that. Degree 3 means we need to find how many zeros? 3 zeros. That's right. And looks like they gave us a 0 to start with. Okay, hold on. They said given -2 plus 5i is a 0. Now, isn't that a non-real 0? I'm going to go ahead and add something then. You guys learned about conjugate zeros theorem, okay? If -2 plus 5i is a 0, then -2 minus 5i is also a 0. Hooray! Guess what? We just found 2 answers, okay? So if I just organize my zeros thingy, zeros, okay? I need 1, 2, and 3. And the reason I say we need 3 zeros is because the degree is 3. We know the first 0 they gave us was -2 plus 5i. But using the conjugate zeros theorem, we also know that -2 minus 5i is also a 0. Listen, can the third one be an imaginary 0? This must be a real 0. And let me tell you why, okay? Because we talked about how imaginary must come in pairs, okay? It must always come with one partner, okay? But we only got a blank for one person, okay? So the third one, that can't be imaginary because imaginary needs to come in pairs, and I only have one blank left. So this must be 0, a real 0. And I'll tell you an easy way of solving this. If it's real, we'll be able to see it. So this is what I'm going to do. I'm going to go ahead and just, this is what I'm doing is a shortcut, by the way. I need to show you the longer way. But I am going to Desmos graphing calculator. Unlike imaginary zeros, real zeros, we can see them. Where are they? They are the x-intercepts. So let me real quick graph that function and see if I can actually see the 0. We just need one more, you know, right? Why is my computer so slow? All right, guys, hold on a second. I'm going to go ahead and type that function in. P of x equals x to the third power plus 3x squared plus 25x minus 29. And look at that. I see a 0 at 1. So I'm sorry, guess what? Guys, I solved it already. I found the answer already. The third 0 is 1, and I just saw it from the graph. But you know, this what I just did, guys, is kind of a cheating method, right? But hey, I used the conjugate zeros theorem, and I also know that the last one must be a real 0 because I only have one blank left. I think this was good. So what did they want us to do here? Let me read the direction. Find all other zeros. We're done. We found all the zeros. I'm done. I found 3 zeros and I'm done. But this is probably not the method that we can use if we do not have a graphing calculator. So I'm going to show you the longer method, okay? But if I were you, knowing that you guys are allowed to use your graphing calculator, I'll do this, okay? This will work. But I'm going to do it the longer way, okay? So I'll do it this way, okay? Because using the fact that these two are zeros, I'm going to write factored form, okay? So the first factor is going to be x minus -2 plus 5i. Agree? Now the other factor is always x minus and the second zero of -2 minus 5i. Let us multiply this, because if we multiply these complex conjugate pairs, it's gonna come out like a nice trinomial, like you saw. I like to get them out of the parentheses first by distributing their negative. If I do that, I will get x plus 2 minus 5i, and I'll get x plus 2 plus 5i, right? And you know, you have to decide now, which method did you like better in my previous video? You do your method, but I'm gonna do my method. I'm gonna do my box. I like my box, you know? I'm gonna draw 3 by 3 box and then label everything x, 2, and -5i, and I have x, 2, positive 5i. And I'm going to do my multiplication in these little boxes. I'll get x squared, 2x, -5ix. Next line, 2x, 2 times 2 is 4. This last one is -10i. Doing good. Bottom line, I'm going to get 5ix, 10i. And this one is the hardest one that I need to be very careful. I'm multiplying -5i times positive 5i, which is -25i squared. But as we know, I squared is just -1. Therefore, the last multiplication will give me 25. I'm going to cross out some like terms or opposite terms. 5ix and -5ix are opposite, so those are gone. -10i and positive 10i are gone. Now I'm left with some like terms, okay? I see a like term at 2x and a 2x. They will add up to 4x because they're both positive. And if I add 4 plus 25, wouldn't I get 29? So this is the answer. I'll get x squared plus 4x plus 29. And I'm not done. I multiplied and I got a quadratic. What I will now do is I will do a long division. I will divide our polynomial of, what was the polynomial, guys? X cubed plus 3x squared plus 35. Whoopsie, that's not 35, that's 25. 25x minus 29. I'll divide that original polynomial by what I just found. What I just found is this trinomial. Okay, I'll write that here, okay? This is x squared plus 4x. Uh-oh, I'm so out of room. Let me see if I can move this a little bit, guys, okay? Give me 1 second. Plus 29. Okay. Now, we know that is a factor, so the remainder will come out to be 0. But what I'm focused on is I am determined to find the quotient, because quotient is going to be the last linear factor. Let's review polynomial long division. I divide x cubed by x squared, which is going to be x. I multiply x to this trinomial, and I'll put that trinomial down here. Remember the long division? So this will be x cubed. Oopsies. Oh, oopsies, what happened to my pen? Guys, my Apple Pencil just died on me again. Alright, I'm gonna go ahead and pause this video real quick, and then I'll record again when it charges. They charge so fast, so I think it's charged enough for me to go back. Alright, so I'm back over here. I was doing the long division. So I will get x cubed. Come on, pencil. Oh, it's working. It's just slow. Right, hold on. I'm very sorry, guys. I wish I knew how to edit videos. Like, take out the part that I don't like. I don't. Okay, so I'm over back here. Multiply x cubed I'll get plus, hold on a second, let me highlight the things I'm doing. X times 4x is 4x squared. Okay, I'll write down 4x squared here. And then I multiply x times 29. That is 29x. Let me write that over here. And then I subtract vertically, okay? And you know, I usually change the sign and add instead. But whatever you do, you will get negative x squared because 3 minus 4 is negative 1. And if I do 25 minus 29, wouldn't that give me negative 4x? Negative 4x. And I'm going to bring down the negative 29. Okay? And we do the division again. Let's divide negative x squared by x squared. Okay? Well, that's going to be just negative 1, isn't it? If I do, like, remember, you see? If I divide negative x squared by x squared, that is just going to be negative 1. That's why I put the negative 1 up there. Okay? Now, I need to multiply all this trinomial by negative 1. Then I will get negative x squared minus 4x, lastly minus 29. And if I subtract vertically, if I subtract anything by itself, what's that going to be? It's going to be 0. So, yes, we were right. This was a quadratic factor. This little guy that we found is the quadratic factor of our p, of our polynomial. Okay? And we found the linear factor. We know who this was. This was a multiplication of a quadratic and a linear factor. Now look at this x minus 1 for me. If x minus 1 is a factor, what is a 0? I'm going to use all these fancy tools on my writing pad. If x minus 1 is a factor, then x equals 1 is a 0. So what I did down here, I wanted to connect what I did on the graphing part. Like I was able to see that 1 was a 0 with some algebra. Okay, so that when we are left with no graphing calculator, we still know how to do this problem. But that is it for this example.